We'll start by grading Learning Opportunity 7.9. I'm going to go through the answers like we would at the start of class. You can go ahead and keep track of how many you missed and send me that minus number by the end of the day today, please. If we go through this part, the grading, and you got them all right, you can skip past this video to do today's notes, but if you missed even one, I hope you'll fast forward to the problem you missed, because I'm going to go through them all after this slide right here. Number 1 was 94 centimeters squared. 2 is 104 meters squared. 3 is 9,600 inches squared. 4 is 73 meters squared. 5 is 25 and 92 hundredths centimeters squared. 6 is 356 hundredths meters squared. 7 is 846 inches squared. And the surface area for number 8 is 1,200 inches squared. The answer to the riddle, what happened to Mr. Colby after he swallowed 2 nickels, 3 dimes, and 1 quarter? There was no change. Now, these were all rectangular prisms. It was probably a little bit easier than the more recent assignments. So you also had a bank of answers to refer to, so that if you didn't find your answer, you probably went back, hopefully, and went through your work and found a mistake. So there's a good chance you have -0. If that's the case, you can skip forward to the notes on the next slide. If you missed any of these, please stay and watch the explanation of the problem you missed. I'm going to do a little shortcut on these. Rather than label them faces A, B, and C, I'm just going to go ahead and, like for example, this one, I can see it's 3 times 4, or 12, the area of that rectangle. The area of this rectangle is 5 by 3, so 15. And the top face, there's a 4 here and a 5 here, so 5 times 4 is 20. So I've identified the area of each of these different rectangular faces, and I know that the surface area is going to be 2 of each, because for each face there's a parallel and congruent face on the other side of the rectangular prism. So I have 2 15s and 2 12s and 2 20s, so 30 and 24 and 40, 70 and 24, 94 centimeters squared. Number 2, we have a 2 by 5, so 10 for the area of this small face. This big front face is 6 by 5, so that's 30. That's the area of that face, that's the area of that face. This one is 2 by 6, so 12. That's the area of the top and the bottom faces. So I have 2 30s and 2 10s and 2 12s. So 60 and 20 and 24 is 104 meters squared. Number 3 is a cube, so each face is 40 by 40, which is 1600. I don't need to do them in pairs because I have 6 faces that are 1600. All faces are congruent, so that's 9,600 inches cubed. Number 4, this face where I can see both dimensions, 5.6 multiplied by 3.1. Do some mental math. Hold on while I do some quick mental math here. That's 17 and 36 hundredths for that face and the face opposite it. This face is 2.2 times 3.1. That is 6.6 and 0.22, 6.82 for that face. And this face is 5.6 by 2.2. 2 5.6s is 11.2. Another 1.12. 12.32. So I have 2 of each of those. So 2 6.82s plus 2 17.36s plus 2 12.32s. That's 24.32 34.64 for this term. This term is 34.72, and this term is 13.64. So adding my holes, I have 128, 130 plus 70 more is 200 hundredths, which is 2 holes. Add that to my 13 holes, I get 15 holes, plus 34 is 49, plus 24 is 53, plus 20, 73. 73 meters squared. It's surprising that comes out to a whole number with so many decimal areas going out to the hundredths. Those dimensions were obviously carefully chosen, I suspect at least. This one is interesting. It's a little different. This face, the 2.7 times 1.8, I'm going to do that on a calculator real quick. Those aren't friendly numbers that I can quickly do in my head. Or at least I'm not seeing the way to do it quickly. 4.86. But then this face also is 1.8 by 2.7, so it's also 4.86. So sometimes you have a shortcut. You don't need 3 pairs. There's 4 of these that are the same. The top and the bottom faces will be different. They're 1.8 by 1.8. I really should know 18 squared. I'm a little embarrassed that I don't. I want to say it's 324, but I could be wrong. Yeah, so 324 hundredths, because the tenths times tenths is hundredths, so 3.24 for the top and bottom faces. So I have my surface area is 2 3.24s plus 4 4.86s. So you see how your surface area formula changes depending on how many faces are congruent to each other. So the surface area is 6.48 plus 16, 19.2, and another 19.44. So 25.92 centimeters squared. I'm going to glance at my answers and make sure I got that right. I did. Here we have 5.8 by 6.3. $36.54. This dimension is 6.3. This dimension is 5.8, and this dimension is 9.4. So for this face, I've got 9.4 times 6.3, which is 59.22. Do a quick estimate. Let's call that 10 and let's call that 6. 10 times 6 is 60. That's close to 60. That seems reasonable. This one is 9.4 times 5.8. I'm also expecting something close to 60, but a little less than we got on the last one. 9.4 times 5.8. 54.52. So my surface area will be 2 59.22s plus 2 54.52s plus 2 36.54s. We do that last one first. That's 72 73.08. 2 54.52s would be 109.04. And 259.22s would be 118.44. Adding up these holes, I get 227, 230, 300. And adding up the hundredths, I have 44 and 4 and 8 is 56. So 356 hundredths meters squared. Don't forget that it's square meters because the total, it's the sum of all the areas, and area is two-dimensional. It's the amount of two-dimensional space taken up by the surface of each prism. They didn't draw a picture here, so I grabbed a picture. You could draw a quick sketch. I went over this on the homework help video. Rectangular box is 12 inches wide, 15 inches long, and 9 inches high. So that's a 12, that's a 15, that's a 9. My 12 by 9 faces will be 108. My 9 by 15 faces will be 135. And my 12 by 15 faces will be 180. So I have two 108s plus two 180s plus two 135s. Two 135s is 270, two 180s is 360, two 108s is 216. And so I've got 576, 646, 846, 846 inches squared. Finally, they refer to two cubes, but they don't show us the cubes. Certainly wouldn't need to draw both of them. As long as you know you have two and then double it. I don't know why I put 2 on here, but each face has an area of 100. You don't really need to label them all as long as you know that there are 6 faces on each cube. And so you could do it 2 of these, or you could do 6 times 100 plus another 6 times 100. However you look at it, it's 1200 inches squared. Okay, report that grade to me.